All right, so this is take 3 of my presentation. For my water property, I chose the universal solvent. How water is a universal solvent. Here is our molecule of water, H2O. You can see right here, H2O. We know that H2O is a polar covalent bond. Polar meaning that there's one side more negative and then one side more positive. So it's like torn. It's unbalanced. I should say. Well, it's not unbalanced. It's not neutral. Like there's not a side that's like happy. And basically, since oxygen's more up to the right, upper right, it's gonna have a tendency to be more electronegative, meaning it's gonna take more electrons away from the hydrogen. So if that's the case, if it's taking away electrons from the hydrogen tends to be more positive. And that makes sense because hydrogen's more up in the top left. Yeah, very top left. And that's why it's polar. So, it connects easily. So oxygens can attract to hydrogens, and then hydrogens can attract to oxygen. And here we have NaCl, also known as sodium chloride, or also known as salt. So on the right side, we have sodium, and since it's on the right, tends to be more positive, and then on the other side, we have chlorine or chloride in this case, and it tends to be more negative. Yeah, this is not a covalent bond. It's an ionic compound, but it's still polar. So this helps us understand that since it's polar, it potentially can be dissolved in water. And here's a picture. Again, sodium's going to be more positive and chlorine's going to be more negative. So hydrogens are going to attract to the chloride or chlorine, since hydrogen is positive, chlorine is negative. And oxygens are going to attract more to the sodium, since sodium tends to be more positive and oxygen tends to be more negative. And here I have water. I already poured in salt from the last ones, but this should be fine to demonstrate too. And you can see it in. It should start dissolving. The particles in it should start tearing each other. The water should start tearing the salt apart. And here we have oil. Oil is important because as you see in a bit, I will demonstrate what it does and its effect to water. Poured in a little, and immediately the oil just went up. I poured it in, it bounced in, and then it just went back up. Now, why does it do this? Well, because oil up here, it's non-polar. We see this compound right here. What do we see? Hydrogen is all the same. It's all the same. There's not a side more positive than there is negative. So it's neutral. There's no sides positive or negative. And this makes the thing happy. So there's no way the polar substance is going to be able to make a non-polar substance dissolve. And yeah, that was my presentation on water, on why water is a universal solvent. See the salt's still down there because this is not pure salt. This is not pure sodium chloride, but most of it's gone. You see, it's quite disappeared. Here, like that is the well, this is my presentation. Thank you guys for watching. This is Samuel Carrillo, 7th period AP Biology, Miss Shooter. Thank you.